Hello, this time I will present you a classic 7-segment display alarm clock, which will represent another one from my series of do-it-yourself unusual and ordinary clocks which you can watch on my playlists. In this case it is characteristic that is used the STM32 microcontroller board known as Blue Pill. It is a popular and inexpensive development board based on the STM32F103C8T6 microcontroller from ST Microelectronics. The ARM Cortex M3 core offers much more processing power and peripherals compared to typical 8-bit microcontrollers like those found on the Arduino. Its price is also significantly lower than many other development boards with similar capabilities. The code is taken from the RCL radio blog, where you can also find detailed instructions. The device is extremely simple to build and the total cost does not exceed $5 to $6. It consists of several components. STM32 microcontroller board, next TM1637 4-digit 7-segment display module, DS3231 real-time clock module, 4 buttons, and small buzzer. First, let me explain how to install the code on the Blue Pill board. To start programming in the Arduino IDE, you need to add the STM32 board. We go to File, Preferences, Settings, and in additional board manager URLs, we need to add this row. And press OK. Now in the Tools, Boards Manager, we need here to type STM32. Now we can install STM32F1XX boards. I already installed that board. And so we need to go again to Tools and choose generic STM32F103C series. In the Upload Method section, we choose Serial. The simplest way to upload the code is to use a small USB to COM adapter and connect it as shown in the diagram. First we need to set the jumper on the STM32 to program mode as shown in the image. Then we select the COM port that corresponds to the USB to COM adapter and press upload. In my case that is COM3. When the upload is complete, we return to the jumper. We return the jumper to its original position and remove the USB to COM adapter from the PC. Now the code has been successfully uploaded and we can mount all the components. In the style of a classic alarm clock, this device uses a real-time clock module with a built-in battery to store the set time when not connected to power. Now let's see how the device performs in real conditions. Thanks to the 4 buttons, settings is extremely simple. Power on is indicated by 2-second beep, which displays the current time. To adjust the time and alarm time, you need to press and hold the time set or alarm button and use the hours and minutes button to set the desired time. Let's see how that looks like. And to set alarm, hold alarm button. Now alarm is 9:30. We set alarm to 10:50. To set the seconds accurately, set the minutes 1 minute more than real time. And when changing the minute, press the set button to reset the second. You can also adjust the display brightness by simply press and hold the plus and minus buttons. The DS3231 real-time clock contains a temperature sensor, and the temperature sensor readings are shown on the display every 10 seconds, 22 degrees Celsius. So this is the alarm. When the alarm is activated, a sound signal is emitted from the piezo emitter from 1 minute, and if we press any of the buttons in the meantime, the sound stops. And finally, a short conclusion. With its simple design, low cost and easy setup, this STM32 alarm clock is a perfect do-it-yourself project for beginners and electronics enthusiasts alike.